Question number 4. What we can do here is changing this 2 into logarithm function in logarithm function, which means we can write this equation as this. So then what we can do for eliminating this logarithm tens, we can exponentiate them over 10. The 10 base and logs cancels each other, but in here it just gives us multiplied by 10 minus 1 in as a result. There's one. Next step, we multiply both sides by 10 and collecting terms, and we can just solve this one as quadratic equation using quadratic formula, which ultimately equal to 9 plus or minus 3 square root 10. And in the next step, you need to use your calculator to determine the actual value correct to 3 decimal places to give the answers to this question. Okay. It asks, by sketching a suitable pair of graphs, show that the equation cosec x equals 1 plus e to minus x over 2. So from this equation, we can get two equations for our graph. First one is y equals cosec x, which is just 1 over sin x. The second equation gives just this equation. Since we have to draw in this interval, we can just ignore the negatives. Origin. Or maybe we can just ignore the negative y values too. Okay. So you can just substitute those values in your calculator and get the values for this one and this one. So roughly the function gives height infinite. So the graph roughly has this shape. And for this one, the graph roughly looks like this. Slowly decreases. So from here, we can conclude in given interval. Okay, in the second part, in the sequence of value given by the iterative formula, and using initial value x1 equals 2, which converges to one of these roots. Okay, and use the iterative formula to determine this root correct to 2 decimal places, and give results of each iteration to 4 decimal places. Okay, so in the first iteration, x1 is equal to just 2, 0, 0, 0, 0. In the second iteration, we can substitute Q in here, which gives 2.3217. And again, in the next step, you need to substitute x2 value here to the third value. Throttling this. And in the next, it's this one, the fifth iteration. And this one, the sixth iteration. It's this one. The seventh iteration gives. There's the eighth iteration. It's this ninth iteration. Also gives this. So from here, we can conclude that it converts into root that has value of 2.292816. So the root one most likely is the value of this. As it said, we have to determine this root correct to only 2 decimal places, and we just have to write our answer in 2 decimal places, as I shown here. Okay, the sixth question. Okay, the first thing to do, we have to find our value r. So to find the value of r, it's just this one plus squared and added. Here is our r value. Okay, in the next part, we have to determine the alpha value. So to simplify, we can just draw a triangle. We have to find this angle, and we can say x value, the x value of this triangle here is just square root 6, and the y value is just 3. In this case, we can just find alpha using tan alpha equals 3/6, and the alpha is just 10 minus 1, this, which gives us alpha value of this. It's just square root 15 cosine theta is this. Okay. So to solve this question, we have to change our formula a little bit, so that in this case, theta is equal to just x over 3, equal to 2.5. And which is actually just equal to this one. Dividing the both sides by square root 15. Then we have to take cosine minus 1. So here you need to, so cosine function can give us 2 values in here. One is positive, one is negative. So in this case, we have to solve for zero interval between 0 and 360 degrees. So we have to consider both plus and minus versions. First, I think we have to just solve for x at the first. So here we have to get our value from here first. So from here it can give two cases. First is 797 degrees, and the negative version is just negative sign. So one thing to remember, this value, negative 49, is smaller than the 50.77. So in this case, the second case actually can give us a positive value in between our interval. So the x1, if we consider the case 1 here, it gives us this value. In the x2, there are in our x2, just 2.9 degrees. And there we have it, our two solutions for this equation.